Oh man, I already burnt my third toast in a row. What? What are you talking about? Yeah, because I cannot beat the last enemy. Come, take a look. Do it for me, then. Help me get a nice crispy toast. Yeah, okay, come. Hey guys, would you look at what just arrived? Yes, this is as stupid as it sounds. It's a toaster with a freaky LCD display with touch. Let's take a look inside. And you know what the goal is, of course. Why else would you pay 100 euros for such a thing? And what I can directly tell is it does not feature any Wi-Fi, which makes it even more strange that they built such a thing and not even put then Wi-Fi inside. At least it's not like advertised somewhere. It's really only this. Overall, you have like a normal 2 bread slice toaster, like a crumb plate, some informations about it, and also here is no Wi-Fi, FCC mentioned, and so on. It's really strange, but okay. And yeah, of course, the important part is here at the front. Let's get this warning removed, like so, and turn it on. So after plugging it in, it will boot and has this freaky menu where you can basically like slide between different breads and so on. And now you can change the amount of cooking or baking, whatever, toasting. And it's even changing like the images, which is really funny. Other than that, you do not have like much settings, a version number, but what helps to know the version number if you cannot do a firmware update. You can basically, yeah, turn it on. It will count down and will cook your bread. It's really not much, and speed wise, like on this small section here, it's quite fast in hindsight or in foresight to get Doom running. But here you can see already it's a bit laggy and it looks somehow like it's LVGL, and I would expect some kind of ARM processor. I'm not even sure if it's like full touch or like multi-touch, but we will see. Let's open it up. Make sure to disconnect power before putting any screwdrivers into a 230 volt machine. We have like 8 screws in the lower part, and these are not even like security screws. These are just Phillips head screws. Let's see if we can already access all the interesting parts then already. I'm really wondering if it opens up to the bottom or if it will only like remove the top plastic cover when unscrewing. And yeah, it looks like already that the top part is coming away to some extent. Yeah, so let's just do it that way. Okay, there's more inside than expected, really. It feels like this handle gets away. And now we can just pull up the whole module, including the screen. And then we have like a power module, a power PCB here in the lower part. which has like an 8-pin cable going to the display. And here in the lower part will really just be like a relay for turning on the heat. A magnet here is there to hold the toast part. There is like, okay, a switch for the heating. That's nicely done. So there's not a relay. It's really like a mechanical switch. If you pull it down, it will turn on the heat element. So it's really like a complete mechanical switch. Other than that, yeah, as mentioned, this 8-pin cable. Let's try to get it apart so we can have a better look overall. Yeah, it's still like a relay, which will then turn on the magnet, and this will then turn on the heating element. So you cannot even turn it on remotely if it would have Wi-Fi to basically like heat up your environment without mechanically pulling it down. Then we have a power supply here, which will be just like 5 volt or 3.3 volt. And length of screws. And let's take a look at this like interesting part. We have again 6 screws. Let's just remove them as well. It would be the best to just have the LCD module on the table to work on it, to play around with it and find out more how it works and so on. And it really looks like this is possible without too much hassle and just being able to work on 5 volts and not on 230 volts. And funny enough, there are also some toasters with like the capability of burning images into bread, which would be of course way more interesting to have like a projector being able to burn some random images. Okay, so the rest seems to be like snap fit. And yeah, that gets out. Okay, perfect. Let's put that away again. We now have here like again this plug. There seems to be an unpopulated connector, which might be for an extra module of Wi-Fi maybe. So I would expect there is a different version that has Wi-Fi. It's really strange to not add Wi-Fi to it. Why go this far and not add Wi-Fi to such a device? And okay, that looks interesting. Very little content. Let's see if we can get more into what exactly the chip is. Let's try to turn on the light. Okay, so it's a K660L microcontroller, and then we can see an external flash, which might be something like 8 megabyte or so based on the images we saw. And very hard to focus. But looks like it's just 4 megabyte. Other than that, here's another unpopulated chip. There's the antenna. So this seems to be a module that is just not added to it. The Wi-Fi or the antenna connector that is not connected. Here's another 6-pin header, which could be for a different type of touchscreen. Now it seems to be integrated in the LCD connection overall. Okay, so here it's just I/O pins based on the naming. And then we have like this looks like an RTC, which is not populated. And then you would add like a battery here. But that's really just guessing. Could also be some kind of like CAN interface. Very unsure. Okay, so here on the back is already a battery, so there needs to be an RTC inside of this chip. And yeah, we can also see like the oscillator for the 32 kilohertz. So this is the clock oscillator basically. Then, okay, this looks like a USB connector. So most likely here we have USB. And normally or optional you would have like a USB connector there. And yeah, that's so far for what we can see just with this info. I will play around with it a bit and see what I can make out of it. Dump the memory, see if we can have some debug interface to the main chip. And yeah, I will get back to you. Some very first results. I desoldered the SPI flash, dumped it, and connected a UART interface to the labeled pins. Without the flash, the chip is not running and basically the screen stays black. And on UART only an A comes in. So it's basically inside some kind of bootloader and waiting for data or waiting for a flashing of the image. For once, if we take a look inside this SPI flash dump, we can see we have here this AEC header inside. And this already looks like some kind of interrupt vector table. So we basically have here like the RAM stack pointer and most likely the code to be executed. But let's look at that later. If we now power on the device, we even get such a nice boot log, and that it is from the company, or that this chip is a so-called RTIN chip, whatever that means. And if we now even send back something to the chip, we also get some very nice help menu. And it seems to be an RTOS. So that's where the basically UI comes from. And that way we can now play around with it. And the SPI flash is 8 megabytes. It still needs to be figured out how much RAM on this chip is. And if we know it, then it's basically open to run Doom on your toaster, which is really cooked. So, quick update in the middle of the process. So, original this K660L SoC seems to be just a rebranded one or renamed one. And it's original D133CBS. And after now, fighting with the pinout, the display, and a nicely shared SDK by the manufacturer, we are able to compile a new firmware, which you can see here in the background, and upload it with this nicely Chinese tool. After spending a few hours in reverse engineering the original firmware to find out exactly what settings the display and touchscreen needs, we can flash a new firmware and turn the device around, of course. Turn it on and we'll be greeted by a nicely LVGL demo screen with a usable touchscreen and also logging on UART again, and even like video playing works just fine. So nothing is stopping us really from getting Doom to run on this toaster now. Let's continue. And would you look at that? Not only do we have full Doom running, we also have a nice interface now and can like start a new game. And now you would likely need to push the lever down to start the game. And only if you ever finish the level, your toast is going to pop up basically. Now let's put everything back together and play a few rounds. So there we go. The fully finished Doom toaster. It features all the necessary parts you would need to ever make a toast. To start a new game, you basically click on Start, select the new game, select your difficulty level, and the middle one is really hard already, so the nightmare mode would, you would basically fail. And then you can just push down the toast. It will start to heat up. You can see it glowing. And now you need to finish the level to be really, to have a fully toasted toast. And before that, the toast will just simply not pop up. And should you die on the way to it, let's just emulate it by letting the enemies kill us. Just a few more damages and we will die. And you can see the timer is running. And now we are dead. But the timer, of course, continues, even if we restart the level. And this time, let's just get a bit of shield here at the stairs. And overall, this microcontroller inside is really nice. And I really like it by now. It's a bit comparable to the ESP32P4, because that one also just does not feature any Wi-Fi capabilities, and it's just a blazingly fast display controller basically. And in this case, you really don't need anything else. A Wi-Fi would be nice as a gag for this toaster, of course, but needing is a different story, of course. Yeah, let's try to walk through the last enemy and not kill him, because that is the most damaging one. And yeah, we finished the level. It will now show the complete time, how many enemies we killed, how long it took. And yeah, basically that's it. And after that, you have a perfectly crisp toast. And yeah, that's all for this toasty story. I hope you liked it and had a bit of fun watching how to get into it and really how to build something around it. While it is not too deep what I explained, it still showed a little bit of how to proceed into it. Getting into the SDK took a bit of time to get really like the display working, and reverse engineering the original firmware was as well not the simplest, because there are so many hidden dynamic RAM configs that were needed to be first found and built into the new firmware. But other than that, this chip really has like 8 megabyte of PS RAM, and now the external 8 megabyte of flash. So it's with 60 Hertz refresh rate, also fairly fast. And if it would not be in a toaster and in a nice device, you could really build something great out of it. And it's really not even that expensive, some Chinese chip. And yeah, hope you like it. See you next time. Until then.